Hello and welcome to the Advanced Topics in Safety module. This is part of the Safety Critical Systems Engineering MSc course here at the University of York. The module was developed by the Assuring Autonomy International Programme, which is funded by Lloyd's Register Foundation. This module aims to transform state-of-the-art research into useful training and education for engineers and practitioners who work with safety-related systems. This video provides an overview of the structure and contents of the module so that you can navigate them better and achieve the most out of learning on the course. The last year has seen radical changes in how we understand learning and content delivery in academia, and for this module specifically. To help you understand these changes and support your learning, we'll cover 5 aspects that are relevant to this module. These are the learning models, the lecturers and contributors, the learning outcomes, timeline, and the link to research. The traditional model of physical lectures and exercises does not translate well to an online environment. So we've adapted 2 pedagogical models to help us to optimize your learning. The first is the blended learning model, which describes how we deliver the content to you. For this course, it's a mixture of online self-study and online live sessions with instructors. The second is the flipped classroom model, where we expect you to watch lectures and work through materials on your own beforehand, then use the live sessions for active learning and exercises, thus making the sessions more student-led, hence the name flipped classroom. The second important aspect of the module is, as a result of online delivery of lectures, we've been able to curate recordings from active researchers and lecturers in their respective fields, and build a course with the experts providing the material. This means that we have over 10 contributors from at least 3 groups and departments. Mark and Nikita will be the main instructors for this course. By the end of this course, you should meet these 8 learning outcomes. Note that not all of these will be learnt through lectures. A large number will be satisfied through self-study and group exercises. Underlying these outcomes are 3 objectives. The first is to provide you with a broad overview of current state of the topics and the challenges. The second is to help you identify points of change in response to the introduction of autonomy. And thirdly, it is to inform you of the approaches and the principles that are being used to manage these changes and address the challenges. The module runs over 3 weeks, with the assessment released in week 4. Weeks 1 and 2 are self-study weeks, where you will be predominantly going through lectures and materials. On Friday of week 1, you will be provided with a topic for a mini research project. Part of your time in week 2 is expected to be spent doing independent research. Week 3 is primarily for the live online sessions and group learning exercises. Note that there will be 1-hour question and answer sessions, Monday to Thursday in weeks 1 and 2. Whilst we don't recommend you miss any of the live sessions, as a minimum, you must attend all 3 Friday plenary sessions and your group's research topic presentation on the Thursday of week 3. The module has been divided into 7 learning blocks, 6 of which are part of the core learning for the module. Each of the blocks is derived from an active research area in safety of robotics and autonomous systems. This diagram shows part of the AAIP research strategy to give context to the blocks. There are essentially 3 levels for this diagram: environment and societal, corresponding with blocks B and C, system level, corresponding with block D, and algorithm component level, corresponding with block E. Whilst material from the 6 core blocks can be learnt in any order, we recommend the following path to build on concepts. Block 0 and Block A should be the first 2. Block 0 is a non-compulsory learning block that contains materials that may help you understand many of the topics or concepts that are covered in other learning blocks. Block A provides an introduction to and explores the challenges of robotics and autonomous systems. Block C deals with the types of safety risk analysis for both the systems that use autonomy and the environment within which they operate. Block D looks at system and component level aspects for safety assurance of RAS, in particular sensing, understanding, and decision making. The last three core blocks are B, E, and F. Block B can be explored after Block A, but it may be beneficial to come to this block after gaining an understanding of assurance process and challenges in C and D. This is because Block B deals with the legal and ethical implications of RAS. Block E has materials related to machine learning and the safety of ML. Finally, Block F provides a broad overview of highly relevant topics. The learning from each of the core blocks is supported by 3 case study exercises that let you get a little hands-on experience with some of the concepts and approaches contained in the lectures. The arrows show which blocks each respective case study relies on. Another important aspect is the independent mini-project. Here you will be assigned a topic related to the safety of RAS, or you are welcome to define one yourself. You are then expected to spend a portion of your time researching this topic. The output of this activity is a short report and a short presentation to your peers for feedback. The final summative assessment is based on the material from all the core blocks and will evaluate how well you have met the learning outcomes. Even though this course is being delivered remotely, we really want to engage with you and for you to engage with other students on the course. There are 3 main ways you can do this. By emailing the instructors directly, by posting on the module discussion pages on the VLE, and by using the module Slack channel. Thank you for joining us for this course. We hope that it provides you with the knowledge and skills to approach the assurance of robotics and autonomous systems.